Hello, I'm Carlos Suarez, and this is the CRS channel. We are going to continue with our physics problems in kinematics, and we will pass on to problem 11. And problem 11, we have that two balls are connected to the ends of a rod of length L. We have two balls, A and B, and this is the rod that connects them, that is of length L. The balls slide along guide rails that are perpendicular to each other. These are the guide rails. Ball A slides to the left with a constant velocity v. Find the velocity vb as a function of the angle theta. Describe vb relative to v. Is vb always smaller than v, larger than v, or the same as v, or does it have some other relationship? Okay, so at t equals 0, x equals x0, y equals y0. From the figure, you can notice that x equals L cosine theta and y equals L sine theta. You have that dx dt equals L derivative of cosine of theta with respect to t. That is equal to minus L sine of theta d theta dt. That is equal to v. Sine of theta d theta dt equals then 2 minus v over L, or equals minus v over L. If v is constant, then sine theta d theta dt is constant. Now dy dt equals L d of sine of theta over dt. That is, or d of sine of theta dt, which is equal to, or equals, L cosine theta d theta dt, which equals vb. vb over v equals minus cotangent of theta. So vb equals minus v cotangent of theta, which means that vb is not constant. Okay, here we have a small table for values of theta, cosine theta, sine theta, and cotangent theta, or cotangent of theta. This value appears given, but with respect to the physics problem, does not correspond actually to a real situation for the physics problem. So we have then that theta should vary within the interval 0 pi halves. At pi halves, here we can assume that it's a closed interval here at pi halves, but it is open at 0. At theta equals pi halves, the motion should stop as the rail corresponding to x ends. So ball A would reach here, and it wouldn't be able to move any further. So by looking at the values of cotangent of theta, we know that cotangent of theta is greater than 1 for theta from 0 to pi fourths or 45 degrees, and is less than 1 for theta greater than pi fourths, that is from pi fourths to pi halves, or from 45 degrees to 90 degrees. So that means that the VB is greater than the speed of A, the absolute value of V, the magnitude of V. For theta from 0 to pi fourths, it will be equal to the magnitude of V at theta equals pi fourths, or theta equals 45 degrees, and will be less than the magnitude of V for theta for theta between pi fourths and pi halves, or 45 degrees and 90 degrees. Okay, one can, beyond that, one can consider the relations between the two distances, that is, the distance traveled by ball A and the distance traveled by ball B. Distance traveled by ball A is given by L cosine of theta 0, is the starting point, minus L cosine theta. That gives L times cosine of theta 0 minus cosine of theta, which is equal to minus 2L sine of theta 0 plus theta over 2 times sine of theta 0 minus theta over 2. That will also be equal to 2L sine of theta plus theta 0 halves times sine of theta minus theta 0 halves. The distance traveled by ball B will be equal to dB equals L sine theta minus L sine theta 0, which equals L sine of theta minus sine of theta 0, which equals L sine of theta minus theta 0 halves cosine of theta plus theta 0 halves. Okay, now the two distances can be compared. The case in which dA is greater than or equal to dB, and we have that we can cancel out the 2's, and we can cancel out sine of theta minus theta 0 halves, and we are left with sine of theta plus theta 0 halves for dA and cosine of theta plus theta 0 halves for dB. So that if dA is greater than or equal to dB, sine of theta plus theta 0 halves is greater than or equal to cosine of theta plus theta 0 halves, which means that theta plus theta 0 halves is greater than or equal to pi fourths. Now, since theta plus theta 0 halves is less than 2 theta, which is less than or equal to pi, that means that theta plus theta 0 halves is less than pi halves, which means that actually for dA greater than or equal to dB, we have that theta plus theta 0 halves is less than pi fourths, is greater than or equal to pi fourths, but less than pi halves, so that theta plus theta 0 is greater than or equal to pi halves, but less than pi. That is that theta is greater than or equal to pi halves minus theta 0, but less than pi minus theta 0. Now, if pi minus theta 0 is greater than pi halves, then we have to substitute pi minus theta 0 with pi halves, since theta will only reach up to pi halves. So it means that in that case, theta is greater than or equal to pi halves minus theta 0, but less than or equal to pi halves. Okay, if the two distances are equal, and that means that theta equals pi halves minus theta 0. Now, if dA is less than dB, that means then that theta plus theta 0 halves is less than pi fourths, and therefore theta plus theta 0 is less than pi halves, which means that theta is less than pi halves minus theta 0. I suggest that you, the viewer, verify this using a calculator and assuming several values for theta 0 and theta. Okay, now we'll continue with the last problem for the kinematics set or problem set, which is problem 12 in the next video.